Hello, my name is Errichto. Today I will show you how to test your solution during a contest or after a contest when you want to solve a problem. I'm using here Linux, but in Windows it should be similar, just the script will be different. And the whole thing should be especially useful during, for example, Polish Olympiad in Informatics, when during second stage you can submit a problem, a solution, but you will not know the full score, so it's important to test your solution. Also, when you know that the verdict is wrong answer, it's good to find a counter example, counter test, where your solution fails, so that you could analyze this test and see what your program does and what it prints on that test. So, as an example, let's think about a very simple problem. Given a sequence of distinct elements, we want to find the second smallest element. So here we have an almost correct solution in n log n. This problem is possible to be solved in O of n, but it isn't important here. So here I read the input, then sort it, and print the second element in the array, in the sorted array. This should be second smallest element. And file in contains a sample input with a sequence 10, 30, 20, 40. I can run my program on this file, and the printed value is 20. What is correct? Here the second smallest element is 20. But let's say I want to test my solution, or I got wrong answer. For that, I write a brute force. It's good not to copy anything from my main solution. For example, it's easy to copy how I read the input or store the array, but maybe a mistake is exactly there. So here I've written this from scratch. So I even read in a different format with cin instead of scanf. So here I create a vector for my array, I read it. And I just use a different technique here that will result in O of n square complexity. So for every element, I count elements smaller than this one, and if there is only one smaller element, it means my current element is second smallest one, so I print it. If I run my brute force solution on the input file, again 20 is printed. So with my two programs, I can write a few tests by hand. For example, I can to file into, save a test, I don't know, n equal to 3, and the sequence should be 2, 6, 4. Maybe this would be fine, or I don't know, 2, 4, 6. And I run my first program, my second program, and they both print 4. And let's say that I didn't find a counter test this way by trying a few different small tests written by hand. Then I want to add a generator, something that will give me a random small test. Here I want to generate a sequence of distinct elements. So the goal is to choose n from some interval. Let's say that n must be at least 2. So here I generate n from interval 2 to the 10. I use a function rand. So in C++ we have rand that returns random value from 0 to rand max. That is usually, I don't know, 2 to the 32 minus 1. But with this function, I can return a random element in some interval, what is very useful inside the generator. So here I use n is random from some interval, then print n, and here print n random elements, each from 1 to 10. Also, I need a set of already used elements, not to repeat those. So here I needed a sequence of distinct elements. Let's say the statement was the input contains distinct elements. So I need to store previous elements and check if something repeats. If yes, I need a different number. An alternative approach to this one would be to, in a while loop, try to generate a sequence, the whole sequence of n numbers, then check if there are some repetitions, and if yes, print and terminate, Otherwise, try again. That would also be fine. I want my generator to produce different sequences. For that, a very useful thing is using a different seed in your rand function. In C++, srand of some value, for example, srand of 50, we'll put 50 as the initial seed, and different random values will be generated from that. And to make that automatic, I put arg of 1 as a seed, then atoi changes a string, well, an array of chars into a number, and I use that as a seed. So actually, then if I run gen, and let's say I put some extra values here, like 1, 2, 3, BAC, blah, 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 then all these strings, so these words, will be given to the main function in C++. Here, the first value, int, is the number of arguments, and the second is an array of arrays of chars. If I say that this is arg, then here I have a drawing for that. So if I run gen with some arguments, then the first thing is arg of 0, then arg of 1, and so on. And the number of spaces between doesn't matter. So my goal is to run gen with argument 1, to say that now the seed is 1, now the seed is 2, and so on, and different sequences are produced. Once you're done with this program, it's good to run it a few times, like I did here, to see if indeed different sequences are produced, and whether there are some repetitions. Here I wanted distinct elements, and they look distinct indeed. Let's say that in my, I know that my brute force is n square, so I can here put 5000 as the limit for n. Now gen with argument 1 produces a big sequence, gen 2 also a big sequence, and so on. Now I need to do something automatic, because what I can do is I can run generator with argument 1, redirect that to file in3, then in3 contains the sequence. Now I can run my program on in3, I can run brute force and compare the results with my eyes. It looks okay. But I want to do it automatically and run thousands of small random tests. For that I need a script, and my script is in bash, which is language used in terminal in Linux. So I have a for loop that iterates from 1 to 100. This is exactly how a for loop looks like in bash. You can treat those do and done as brackets, just like in C++ you would have this kind of brackets. And remember that these standard brackets are double here. So you must put 2 pairs of brackets. And here I just print, echo means print this value. So if you want to use a variable in bash, you must put a $sign here. So just this program should print values from 1 to 100. Let's check that. Bash s and script name. So this is my file, s.sh, and bash runs it. Indeed, values from 1 to 100 were printed. Now what I do is I run generator with seed I. Remember about the $sign. I put that to a file int. I could use here just in, but usually, at least me, for in, as in I use the sample test, so I need a different name. Like you can put in3 here, or I use int. And then, so this is a random test. Then a run on int is redirected to out1, so this is one output. Then here it's output of my brute force. And then I want to run function diff. That is a bash function, bash program, that compares two files. So let's first consider this version. If there will be some difference, then diff will return 0, and then break will be triggered. So long story short, if you put here OR, like double pipes, and break, then once there is a difference, for loop will be broken. So let's run this, bash s.sh. Here it shows me that one file was 13, the other 13, and there is no new line at the end of file because my brute force doesn't print new line. What I can do is either fix a program, so here just I forgot about this extra new line, but instead it's better to just add -w, what means don't check white spaces. And now I can run, and everything was okay. Remember about this flag -w that doesn't check white spaces, what also usually isn't checked when you submit a problem. And let's make sure that my bash loop works. So here, if I say maybe if n is smaller equal 1000, print -1, return 0. This should sometimes be incorrect. It was on the first file. Maybe what about greater equal 4000? It broke on the 5th test here. So it checked files seeds 1, 2, 3, 4, it was okay. Then on 5 it broke. And if we didn't do that break in the script, this one, what would happen is this. And then now it isn't an issue. We see that from time to time there is a mistake. But if a mistake occurs once every 500 tests, then it's harder to catch it with our eyes. So it's better to put that or break here. So now it breaks here. Let's add that. Let's fix this. Compile. And now everything works. Actually, this up to 100 isn't so important. It's better to remove it. Now it's an infinite loop because there is no condition to break. Let's run that. And if it runs for a few minutes and doesn't break, then likely my solution is correct. Here, it wasn't correct. So there was a difference in some test. Test number 799, apparently. So how to find a counter test easier? Well, in generator, usually it's much better to put smaller values here. So if you create big tests, it's less likely that some special pattern will occur there. For example, if you generate a tree, if your program breaks on a line, so just vertex after vertex, there's a small probability to get that if you generate a random tree with 5,000 vertices. The probability will be something like 1 divided by 5,000 factorial, what is almost impossible. So now, if I run it just for values up to 10, it broke on the first try. So I can also try 100, that should still be much better than 5,000, and it broke on test number 13. So this is better. And also try not to fix a value of n here, like a 10, because sometimes maybe your program doesn't work only for an edge case or something like that. It's better to, so here a mistake was found, a counter test, but it's usually better to put an interval for that. Here, just put the smallest value allowed in the problem. Here I assume that the problem said, given a sequence of at least 2 distinct elements, find the second smallest element. So here actually during a contest I would do it this way. Here I find a counter test. I can print it with int. So maybe this is too big to analyze. Maybe I got a too big test here. I can try to decrease the values. Maybe I want to n up to 2 and values up to 5. Let me generate that. Again, I found a counter test. now with n equal to 2. So this is easier to analyze. And given this test, we could look at this file and see that actually we don't sort here correctly, because it should be +1 here. But let's leave it this way. Actually, we can add +1 here, and now try it again, bash s.sh. It works. We can again change this to 10, 10, and see now, and again it should work, because I think now the program is indeed correct. If you get wrong answer, but everything works on small random tests, like these ones, then what I think you should check is overflows, because small tests will not catch that. Some edge cases, maybe not generated by your generator, maybe you have too small array. And the third thing is undefined behavior. So maybe everything works on your machine, but doesn't work on the platform. Recently on CodeForces I did a blog about that, about also undefined behavior. So when something doesn't work, what you should do, and I will link that in the description below the video. Let me kill that. You can in terminal kill anything with Ctrl+C. And one more thing in the script is that instead of all of that, you can do the same in one line, because diff can get not necessarily a file, but in Bash you can kind of redirect the output of a program. So here a run on int will return a stream or maybe a temporary file to the output, and by doing this character smaller than, so redirecting, and this in brackets, you kind of give to diff this file or string. You do the same with root, and this is enough. This whole script is enough to remember. Also, you don't need this, but if you run it without echo and you just run bash, you don't know if everything works correctly. You don't know how many tests were checked. Maybe, for example, your program got into an infinite loop on test number 5, but you don't know it. So I recommend printing the seed here to see that everything is being checked. So that's it about this problem. Also, when you want to find for mistakes, maybe you have some runtime error or something like that, I recommend compiling in C++ with flags that will do some extra checking for you. In the description I will put a link to my GitHub repository with all the files you see here, so this ACPP, root, gen, s.sh. Also here you can find my flags for compilation. These are called sanitizers, and they will check, for example, if you have out of boundaries error and similar, and they will break your solution for sure then. But remember that those will slow down your program. If you want to measure the running time on max test, something like that, then instead compile with O2 and without the sanitizer flags. One more thing about testing. If you want to test on thousands of tests, maybe global big arrays will hurt your running time. So here, an array of ints isn't that heavy. It's slow, it's fast, but if I add a set, even if I don't use it, of size max n, and now run my bash loop, it's much slower. Maybe I can add here even bigger array of sets. It should be slower. So for the testing on small tests, it's better to, for a moment, change max n, the size of arrays, to a smaller value, so it will be fast. But at least right here to do, remember to change for a bigger value. But for a comment, it's easy to be forgotten. maybe you will submit then with this value and you will get unnecessary runtime error. It's better to put this as a warning in C++ to do remember about bigger N. And now every time you compile, you will get a warning, compilation warning. And if you care about warnings, and this is what you should do generally in programming, if you get any warning, try to get rid of that by modifying your code. Then before submitting, you will see that something is wrong here, I should change that. And then I would, before submitting, see the warning, then I can comment that, and now there's no warnings because I remembered to change N. So that's it about testing. One last thing I want to show you is how to generate trees, because this is slightly harder than, for example, generating a sequence of numbers. Here you can see GenTree, simple generator for that, where I generate n from 2 to 20 in this case, I print n, and now for every vertex from 2 to n, I generate its random parent among previous parents. So first I have a vertex 1, then I have vertex 2, which gets parent 1, then for vertex 3 I randomly generate whether its parent should be 1 or 2, and I print those edges here. So vertex I will be connected with vertex that is randomly generated between 1 and I minus 1. After printing, after coding such a generator, it's good to run it once or twice with different seeds to see if it looks fine. I think it does here, so it does roughly what I wanted to do. For every new value, 2, 3, and so on, I generate its parent, looks fine. Now, if you want to generate trees in a smarter way, so this generator only will generate some kind of trees. One thing is that always first value in a pair will be smaller, also the first value is 1, and finally with this kind of generator the expected height of a tree, so the maximum distance from a root 1 to some leaf, is only logarithmic. It can be proved because usually here, in short, usually a vertex is connected with a vertex of value roughly I divided by 2, so the distance to root should be logarithmic more or less. If you want to make that smarter, here we can see a better generator. Instead of just printing, here I create a vector of pairs, edges, then I push back edges to that vector, and what I do is here I randomly shuffle edges. Then the other thing is I generate a permutations 1 to n to rename vertices. So maybe not necessarily 1 will be connected with 2, but instead those will be renamed. I generate a permutation of numbers from 1 to n to change the names when I print. So I think I forgot to use that perm here, and when I print here I iterate over edges. A is the first value, B is the second one. With probability 50% I swap the two values, not to print the smaller one first, maybe it's better. And finally here I want to print permutation of A and permutation of B. So permutation means which name should be printed instead of this one. So maybe 1 will be changed to 3 all the time. I can also run this GenTree 2 with seed 1, seed 2, seed 3. So here indeed you see it in a different way than GenTree generated, because then in GenTree 1 the first edge was always 1, 2. Here it's something different. Just be careful with that, because if you make a mistake here, maybe you will not print a tree. So maybe to make sure, then go to your solution and put some asserts that a tree is indeed a tree, that you don't have loops, something like that. But it isn't necessary, well, it isn't required at all if you write this generator in a smart way, in a correct way. If you want to generate some special trees like a line or a star, then modifying this is enough. If you modify this random parent to a 1, for example, then you will get a star, gen 3, 5, 6, 7. So here all vertices are connected to 1. If you modify it to I minus 1, then you will get a line. The same can be done here in a smarter generator. If you put here I divided by 2, then you will get a binary tree. So these are 3 most common types of trees. Also, if you want to experiment even more, you can here not generate uniformly in this interval, but instead you can do something like int x is round in this interval, and then x is round between 1 and x, and put x here. This, so now usually x is slightly smaller than I divided by 2. It doesn't matter that much. Or here, instead of 1, you can put I divided by 2, maybe. So now also it's not so simple. But if you want to just try small tests, this should be enough. So experimenting with lines, stars, and so on is important to generate big trees. To check your running time, maybe to check whether your solution is quadratic for a big tree of some special type. If you want even smarter trees, to generate even smarter trees, then you should read about proofer sequences or proofer codes. I'm going to soon do a video about it, so stay tuned on my YouTube channel. That's it. If you have any questions, leave a comment below the video. I read them all and answer. And for those participating soon in the Polish Olympiad in Informatics, good luck and remember to test your solutions. Bye bye.